Hello guys, in this video we're going to talk about worksheet 9.3b level 2 plus. So this is still in the joint variation and this worksheet is talking about the percentage change. So first of all, I need to remind you, so what is the meaning of the joint variation? So basically in the joint variation, if you're saying that the z is jointly various as x and y, basically you can just write it as the z is proportional to xy, so that I can write the z is equal to k times xy. Or sometimes they said the z is proportional, or the z is directly proportional to x and inversely proportional to y, so that I can write it something like the z is proportional to x, but it's inversely to y, so it's directly to 1 over y, so you can times the 1 over y here, so that I can write as the z is equal to kx over y. And another thing that I need to remind is the percentage change formula. So the percentage change is actually equal to the new value minus the old value divided by the old value. So now we can start to do our question 1. So the question 1 is saying that suppose we have the z is various directly as x. So first of all, we can say that the z is various directly as x and inversely as inversely as the square root y. So we can write it as 1 over square root y. And then to find out the percentage change in z. And there's two cases. So now we can consider about the first one. So when we have this equation, which means that we can say the z is equal to kx times over the square root y. So this is our relationship of the old z, which is equal to the kx over the square root y. So for question A, we have the x is decreased by 3%. So now we have the new x is going to be equal to x times 1 minus 3%, as the x is decreased by 3%, which means this is equal to 0.97x. Then we have the new y, which will give you is increased by 12%. We use the old y times 1 plus 12%, then give you 1.12y. Then we can calculate the value of the new z. The new z can be calculated by using this formula, but changing the z to the new z, changing the x to the new x, and changing the y to the new y. Then we can have the k times the new x divided by the square root of the new y. Then we can substitute our new x value and the new y value inside our formula, then to get the k times 0.97x, then divided by the square root of 1.12y. So in this equation, then we can use our formula of the square root of ab, which is can separate the square root into square root a times square root b. But please bear in mind that the square root a plus b is not necessarily equal to the square root a plus square root b. So this is wrong, okay? So now we can separate our denominator to become the square root 1.12 times the square root of y, and I will keep our the numerator. Then we can separate it into the format of the 0.97 divided by the square root of 1.12 times kx over the square root y. So then we can using our percentage change of z, which is equal to the new value of z minus the old value of z, then divided by the old value of z. Then we can substitute it in the new value of z is this one. Then we can get the 0.97 divided by the square root 1.12 kx over square root y minus our old z. The old z is here. Then we can just put it inside our formula to get kx over square root y, then divided by kx over square root y. So as you notice that the kx over square root y is our common factor, so we can take it out to get kx over square root y, and then bracket times 0.97 divided by square root 1.12, then minus the 1, then divide by again the kx over square root y. Then using a calculator to calculate this, you can get the value of this is going to be equal to negative 0.0874. Change it back to the percentage number, we can get 8.74%, but in the negative. So make sure that every time you bear in mind the negative sign, because negative sign means that it's the percentage decrease. Okay, and we're taking the three significance figures. All right, so that's for question 1A. And for question 1B, I think it's the similar approach, so I'll just leave it there. And the question B's answer is going to be 7%. So try to do the question B by yourself. If you have any questions, just WhatsApp me. All right, so now we're going to do question B. So the question B is like very long questions, long wording questions. We can try to look at it. So now we have our force. So force of something is acting on a vertical surface by the wind. So all the things here. So for example, you can say that this thing is actually, you can just ignore it for the whole sentence. This is just, the whole thing is not really useful. So which means that we can just keep the force. So now we have the force. So the force is jointly as the area. Now we have an area of something and a square of the wind speed. So now we have three variables. The first variable is going to be the force. And the second one is our area. And the third one is our wind speed. So which means that we can take the F as our force. And we can using A as our area. Maybe use W for our wind speed. And they said the force is jointly as the area and the square of the wind speed. So which means that we have the F is proportional to the area together with the wind speed. So this is our equation linked the force, the area, the wind speed. And then we can say that we can change the Fisher sign into the equal to K. Then we have the F is equal to KA W squared. So this is our formula. And then what they said is, so if the area of the surface is increased by 10%, so which means that we have the area is increased by 10%, and together with the wind speed decreased by 5%. So the wind speed is decreased by 5%. So the question is asking find the percentage change of the force. Okay, so now we can know how to do it. We're changing the whole sentence into some formulas, and we have two conditions. So now we can find out what's the new value of area and the new value of the wind speed. So now we can say the new value of the A, which is the area, is equal to the original area times 1 plus 10% as it's increased. So now we have 1.1A. Then now we have the new value of the wind speed, which is equal to the old wind speed times 1 minus 5%, then gets the 0.95 W. So now we can find out the new value of force, which is equal to, using this formula, then we can change the F to the new F, changing the A to the new A, changing the wind speed to the new wind speed. Then we can have K times the new area times the new wind speed squared. Then we substitute the values back into our equation to get K times 1.1A times 0.95 W squared. So for this part, we can use our formula AB squared is equal to A squared times B squared. Then we can calculate out the K times 1.1A times 0.95 squared times the W squared. Then we can take out our numbers. Then we have 1.1 times 0.95 squared. Then we times KAW squared. So now we can calculate the percentage change of F, which means using the new F minus the old F divided by the old F. Then we can substitute our values in. The new F is going to be this whole thing, 1.1 times 0.95 squared times KAW squared. So 1.1 times 0.95 squared times KAW squared, and minus the original force. So the original force is here. Just copy this down. So KAW squared, then divided by the old one, which is again KAW squared. So taking the KAW squared as a common factor, we can say that this is equal to KAW squared times 1.1 times 0.95 squared minus the 1 divided by the denominator again, KAW squared. So as the numerator and denominator both get this KAW squared, we can just eliminate them. And using a calculator to calculate the whole thing, you can get the answer should be equal to 0.00725 in the minus, so which means that is equal to 0.925%, which is a percentage decrease. So you will have a negative sign So this is for question 2, and now we're going to move to question 3. Again, question 3 is a long question, but don't afraid about it. Just trying to change the whole thing, the whole wording questions into some formulas that you're familiar with, then we can try to do it. So the first thing that is saying is the weight. Again, the weight of something is not important, so we can just delete. The weight of a load that can be supported by a wooden beam is useless. The weight of something varies directly, which is important, varies directly as the square of the diameter and inversely as its length. So find the percentage in the diameter if the length of the beam is doubled and the weight is remain unchanged. So first of all, we need to know that we need to tidy up that what we have. So first of all, we have this weight, we have this diameter, and we have this length. So write down the variables that you have. The first one, is a little bit. So the first one we have is the weight, and they're telling us to use W. And the second one, the second variable is the diameter. Then we can use D as our variables. And the last one is the length, and use L. So now we have the weight, the W, is varies directly as the square of D, which is the D squared, and inversely as the L. So it's directly as 1 over L. So we can write as the W is proportional to the square of the diameter, and it's inversely, so we can change it to directly, but make it to be a fraction, so which is 1 over L. Then we can combine them to get the W is equal to KD squared over L. So that's the relationship between our W, D, and L. So now they're asking something very strange. They're asking not the percentage change of the weight, but this time they're asking for the percentage of the diameter. So then we need to change the D to become our subject. As you still remember, that's the percentage change of the D, the diameter, should be using the new value of D minus the old value of D divided by the old value of D. So this is the old value of W. So if we want the old value of D, which means that we need to change D to be our subject, so that we can change it to the WL is equal to KD squared. We don't want this K, we move it to the left hand side, then get the WL divided by K is equal to D squared. So which means that the D is equal to the square root of WL divided by K. So bear in mind why we only take the positive square roots, because the diameter can never be negative numbers, isn't it? So we just take our positive part. So this is our old D. We make the D to be the subjects, then we can have the old D values. Then now we can say that what we're gonna do is to find out our new value of W and the new value of the length. So first of all, you can write down the new value of the length is gonna be equal to, it's doubled here. They say it's doubled, so the new L is gonna be 2 times the original L. So what is the new weight? They're saying that the weight is remain unchanged, so the new W is still equal to W. So now we can find out the new value of the D. So the new value of the D got a relationship using this formula, so that we can write it down as the square root of the new W, then times the new value of the L, then we can divide by K. So now the new W, we can substitute in. The new W is still the same as W. Then we can times our new L, which is doubled, so we have 2L. Then we divide by K. The K is not changed, it's just a constant. Then we give them a square root. So bear in mind that the square root of A and B is equal to the square root of A times the square root of B. So just using this formula, we can separate this square root. So then we can write it as this is equal to, we can take out the square root 2. So we have the square root 2 times the square root of W, L over K. Then now we can calculate the percentage change of D, which is using the new value of D minus the old value of D, then divided by the old value of D. If you still remember that the new value of D is going to be the square root 2 something, so we can write it down as the square root 2 times the square root WL over K to minus the old D. So this is our old D. The relationship between D, W, and L. That's the first thing we find it out by changing the subjects from our original relationship so that we can get the original D, which is equal to the square root of WL over K. Then we divide by the whole thing, which is the square root WL over K. So now we have this square root WL over K, which is our common factor. So we can take that out. Then we have the square root WL over K. Then what we left is our square root 2. So square root 2 minus 1. And then we keep our denominator, square root WL over K. And these two things are the same, so we eliminate them. Then using the calculator, you can probably get this is equal to 0.414, which is equal to 41.4%. I will write again. So this is equal to 41.4%. Alright, so that's for question 3. It's a little bit hard because at the first place, you get the relationship between the W, K, D, and L. Sorry, the K is the constant. So we have a relationship between W, the D, and the L. But however, as the question is asking the percentage change in diameter, so which means that you need to make the D, the diameter, to be our subject. Then we can use our formula of the new D minus the old D over the old D to get a percentage of D. So that's the main difference of this question compared with the others. Alright, so now it's our turn to do a similar question, which is in the DSE exams. It's a similar question types, so we can try to do it as well. So first of all, it's saying that the Z is varies directly as X and inversely as the cubic root of Y. So don't need to scare about this cubic root, just write like the normal things, just write it like a normal square root. So first of all, we have the Z is directly proportional to X, but it's inversely as the cubic root of Y. So we have 1 over cubic root of Y. So which means that we have the Z is equal to the KX over the cubic root of Y. So now we have the Y is decreased for 48.8%, and we have the Z is increased by 18%. So how will the X be changed? So again, now originally we got a relationship between the Z is starting from the Z, right? But however, now we're going to change, we want to find out the percentage change of the X. So which means that we need to change our subject to be X. Okay, so that's similar to our question 3. So try to make X be the subject. So now we're going to make X be the subject. Then we can say that. So we have C is equal to KX over the cubic root of Y. So which means that we can write, we don't want the whole thing. We change it to the left hand side, we times it. Then we have Z times the cubic root of Y, which is equal to KX. Then we have this X as the subject, then we can have Z times the cubic root of Y divided by K. So now we make X as our subject, then which means that X is our old X. Okay, now we have the Y is decreased by 48.8%. So we can find our new value of Y, which is equal to using the old Y times 1 minus 48.8%. Then we can say this is equal to 0.512 Y. And now we can find out the new value of Z, which is increased by 18%. So using the old Z times 1 plus 18% to give you 1.18. It's Z, so 1.18Z. Then now we can find out the value of the new X. So the new X got a relationship between Z and Y like this. So we can write down the new value of Z times the cubic root of the new value of Y and then divided by the K. Then we substitute the value in, then we can have, so bear in mind this cubic root. Okay, so the new value of Z giving you 1.18Z, and then we can times the cubic root of 0.512y, then we divide it by k again. Then if we summarize it, we can have 1.18 times the cubic root of 0.512, then we can times the z times the cubic root of y, then divide by the k. So now we can use our formula, the percentage change of x is going to be equal to the new x minus the old x divided by the x. Then we substitute in the whole thing, we can have 1.18 times the cubic root of 0.512 times z times the cubic root of y divided by k, then minus our old z, our old x, which is z cubic root y over k. then we have this z times the cubic root of y over k. Then we can divide the whole thing again by z times the cubic root y divided by k. I know it's very tedious to write a lot of things there, but I'm afraid that in long questions, you have to write all of the details in there. So again, we're doing the same thing again, and again, isn't it? So this is our common factor. We'll take it out and eliminate with the denominator. So the answer was just like the 1.18 times the cubic root of 0.512 minus 1. Using your calculator, you'll get this is equal to negative 0.056, and changed back to the percentage, we will have the negative 5.6%. Alright, so for this kind of questions, the main thing is to make sure that what's the percentage change you are calculating. So normally, we're just calculating the percentage change of z, but it's not means that it cannot to change the percentage change of the other subjects. So when they're asking for when they're asking for the percentage change of the x, then you just make x to be the to become the subject. So what if this time the question is asking what's the percentage of y, then just make y to become the subject. Alright, so that's for this worksheet. So if you have any questions, just let me know in the WhatsApp. Thank you.